This is a really short video just showing more examples from section 5.1. At the beginning, I already list out all the identities we have in section 5.1 on the left. So we have reciprocal identities, we have the quotient identities, we have the pentagram identities, and then the new even and odd function identities. Okay, so the one we're going to do right now is number 54. Write expression in terms of sine and cosine, and then simplify so that there's no quotient appear and all functions are of theta only. So number 54, talking about tangent of theta times cosine of theta. Since we want to rewrite everything in terms of sine and cosine, so I already have a cosine here. I'm not going to touch the cosine, but I have a tangent theta. So I'm going to rewrite tangent theta using the quotient identity, which is sine of theta over cosine of theta. Since I have, I rewrite tangent theta in terms of a fraction, so it's better to rewrite cosine theta in terms of fraction as cosine of theta over 1. So now I'm going to try to simplify it, try to multiply it. Since I have two fractions, both fraction has a cosine of theta. One is on the numerator, one is on the denominator. That means those two will divide out. So as the answer, I only have a sine of theta. Since sine of theta is my last step and it's pretty simple, there's no way to continue simplify it. It's already written in the sine and cosine form, sine or cosine form, and there's no quotient up here, so sine of theta is the final answer. Okay, so number 54 is pretty short, so I'm going to do number 70s also. Number 70s is talking about sine of theta minus cosine of theta multiplied by another expression cosecant of theta plus secant of theta. So we're going to do the same FOIL method. So we're going to multiply the sine theta with the cosecant theta, sine theta by the secant theta, negative cosine theta by the cosecant theta, and negative cosine theta by the secant theta. So we end up with sine of theta multiplied by cosecant of theta plus sine of theta multiplied by secant of theta minus cosine of theta multiplied by cosecant of theta minus cosine of theta multiplied by secant of theta. Okay. So next, we're going to using identities, which is the reciprocal identities. From the reciprocal identity, we know that secant theta is 1 over the cosine theta, and cosecant theta is 1 over the sine theta. If I'm going to rewrite everything, the secant and cosecants in terms of 1 over cosine or 1 over sine, I'm going to have sine of theta multiplied by 1 over sine of theta plus sine of theta multiplied by 1 over cosine of theta minus cosine of theta multiplied by 1 over sine of theta minus cosine of theta multiplied by 1 over cosine of theta. Okay, so from this line we have two pairs of expression. We can using either the identities or algebras. So the first one we see is sine of theta multiplied by 1 over sine of theta. Just like 2 multiplied by 1/2, 3 multiplied by 1/3, sine of theta multiplied by 1 over sine of theta will equals to 1. Same thing is for the cosine of theta and 1 over cosine of theta. Then the second piece we can see is the sine of theta multiplied by 1 over cosine of theta, cosine of theta multiplied by 1 over sine of theta. From the quotient identity, we have tangent of theta equal to sine of theta over cosine of theta. and cotangent of theta equal to cosine of theta over sine of theta. So if you want to see a little bit a middle step, I can rewrite sine of theta times 1 over cosine of theta as sine of theta over cosine of theta, and cosine of theta times 1 over sine of theta as cosine of theta over sine of theta, which is tangent of theta and then cotangent of theta. So I'm going to continue with the simplifications. 1 minus 1 become to 0. So we end up with tangent of theta minus cotangent. Actually, just writing one more step. Becomes to sine of theta over cosine of theta minus cosine of theta over sine of theta, which is tangent of theta minus cotangent of theta. Okay. So here, the reason for me to write two steps is the first level, sine of theta over cosine of theta minus cosine theta over sine of theta, satisfy the first question is rewrite the expression in terms of sine and cosine. And then the second answer, which is my last step, is the answer after simplification and there's no quotient appears. Okay. So that is how to do number 70. I'm going to do one last question. Is number 74. I think hopefully 74 is a little bit challenge. 74, we have secant square minus 1 over cosecant square minus 1. Okay. So from number 54, tangent theta times cosine theta. Number 70, sine of theta minus cosine theta times cosecant of theta plus secant of theta. To number 74, secant square theta minus 1 over cosecant square minus 1. Seems like number 70 has the most easy question. Number 74 has the most complex question. But because it's complex, that means we have more room to play with it. So in general speaking, number 74, since we have more formula or more identities we can use, is more easier. Comparing to number 70, we do not really have too much to besides rewriting the cosecant and secant and multiply it. Okay, so since we have secant squared theta minus 1 and cosecant squared theta minus 1, those two, not exactly, but those two expressions remind me the Pythagorean identities. So the Pythagorean identity we have, one is the tangent squared theta plus 1 equal to secant squared theta, and the other one is 1 plus cotangent squared theta equal to cosecant squared theta. The question we have is the secant squared minus 1. So if we subtract 1 on both sides, so secant squared minus 1 will become 2 tangent squared, and cosecant squared minus 1 will become 2 cotangent squared. Okay, so I'm going to write a really quick note on the side. So we can rewrite the secant square minus 1 in terms of tangent square theta, and then cosecant square minus 1 in terms of cotangent square theta. Okay. So next, we're going to use the reciprocal identity where cotangent theta equal to 1 over sine of theta, tangent of theta. So I'm going to rewrite it into an actual division symbol instead of a fraction bar. So tangent square theta divided by cotangent square theta. And now I'm going to rewrite the cotangent square in term of 1 over tangent square theta. Okay, so remember, divided by a fraction is the same as multiply by its reciprocal, where the reciprocal of 1 over tangent square theta is just tangent square theta. So tangent square theta multiplied by tangent square theta, we end up with tangent to the 4th power of theta. This one, number 74, I didn't really rewrite it in terms of sine and cosine first, because it's already in terms of tangents and it's much easier. So I'm going to go back to rewriting in terms of sine and cosine. So I'm going to box the tangent to the 4th power as the final answer. Where no simplification, or is already in the simple form, no quotients. Okay, so I'm going to rewrite it in terms of sine and cosine. Tangent to the 4th theta will becomes to sine to the 4th power of theta over cosine to the 4th power of theta. So this one is the right in term of sine and cosine. If you feel like you do not want to use the identities, you want to just follow the instruction, write it directly in terms of sine and cosine, you can do it. So I'm going to redo it. If I'm just going to do sine and cosine, so I started with secant square theta minus 1 over cosecant square theta minus 1. Secant theta is 1 over cosine square theta. Cosecant is 1 over sine square theta. Now I'm going to rewrite 1 in terms of cosine square theta over cosine square theta. And then 1 on the denominator will becomes to sine square theta minus over sine square theta. Subtracting the fractions, keep the denominator the same. And just subtract the numerators. From the identity or the Pythagorean identity, where the sine, and I'm going to write it here, sine square theta plus cosine square theta equals to 1. That means 1 minus cosine square theta will become to sine square theta. 1 minus sine square theta will become to cosine square theta. So 1 minus cosine square is sine square theta over cosine square theta, or over 1 minus sine square become to cosine square theta over sine square theta. So if I'm going to rewrite the long divisions in terms of dividing, don't think I have